Hello, Owls. This is Mrs. Myers, and today we're going to be doing an ACT science practice passage. This is the practice passage that we're going to work with today. It is from June 2023, so fairly recent. And the passage type is experimental design, meaning a scientist did an experiment and then you look at the results. Sometimes for these, you'll have multiple experiments, but for this one, we just have one experiment. Some tips that I would give you for this passage type. First, I would not read all of this. I would skip that. I would skip that. If you're going to read anything at all, maybe read this little section at the beginning just to kind of give you an intro to the passage. But otherwise, you're going to forget what you read and it's going to waste your time. Another tip I would give you for this passage type, it would be to annotate the passage before you start, just finding the big important things that are present. So for example, I outlined in purple the experiment so I can see, okay, these are the steps that they took. And then I outlined in green, you can see here, these are their results. We don't have a graph for this passage, it's just a little table of results. And you can see there are two things in the table. There's their experimental results, so what they found out from the experiment, and there's the accepted value, meaning what scientists already accept to be true, okay? And it looks like then we've got 5 different metals that they experimented on, okay? And then from there, I would just get started on the passage. You can see here how you can tell where to look in the passage for each question. This one talks about CP. You don't even have to know what CP is, but we see CP here in the data, so it's probably going to be asking about this. This one also says CP, so you're also going to be looking here. This one also says experimental and accepted CP, so you're going to be looking here. This one says results of the experiment, so you'll be looking here, and info from the passage. So for this one, question 30, you'll have to look back in the passage. 31 is asking about CP, so again, you'll look here. 32 is asking about specific heat, which also means you can see here specific heat means CP, so you'll be looking here. And then 33 is the only one that you need to look at the experimental procedures. Procedures means the steps the scientists took, and you only need to read these steps for question 33. And again, I would not read those steps word for word. I would skim for the exact info that you need for 33. Don't read it all, you will run out of time. All right, let's get started. Try question 27. Question 27 says, what is the order of PB, SB, and SN from the substance with the smallest accepted CP to substance with the greatest accepted CP? Okay, we're looking at accepted CP, so we know that we'll be looking at these values here. And we're looking at PB, so this guy here, SB, this guy here, and SN, this guy here. They're asking what's the order from the smallest CP to the greatest. So the smallest of these three would be PB. This one's the smallest. And then the next one would be SB. And then the last one would be SN. So it should be PB, SB, SN, which your answer for 27 is C. All right, try question 28. Question 28 says, how many protons are in an atom of the metal that had an average experimental CP of 0.217? All right, so we're looking at average experimental. 0.217 is this guy. So we're looking at the metal SN. Okay, there's nothing in the passage about protons. This is actually one of the rare questions where you do need to know a little bit from your chemistry class. I picked this passage because most of you are sophomores in chemistry right now. Okay, they do tell us the atomic number. Atomic number just means how many protons are in that atom. So SN has 50 for its atomic number. The answer here is 50 for protons. 28 should be H. All right, try question 29. Question 29 says, which of the metals tested in the experiment had the greatest absolute difference between the average experimental and the accepted? So we're trying to find what's the biggest difference between these two numbers. Which one had the biggest difference? All right, let's just go through these in process of elimination. Al, aluminum, you've got this guy and this guy. The difference between these is about 9 1/1000ths. Okay, so we've got 9 there. Okay, B says SB, so here's SB. The difference between these is only 2 1/1000ths. All right, next one is CU. The difference between these is about 4 1,000ths. And then our last one is PB, this guy here. The difference between these is 8. Okay, they're asking which one had the greatest difference. That would be for 29A. All right, try question 31. Question 31 says, for the 5 metals tested, as the atomic number increase, so we're looking at atomic number here, as this goes up, the average experimental, this guy here, does what? Does it go up or down? Okay, so let's start at the smallest atomic number and go up and see what happens to the average experimental. The smallest atomic number here is aluminum, 13, and he is sitting at 0.9. Okay, now let's go up a little bit because we're supposed to increase. The next largest atomic number is 29, and it went from 0.9 down to 0.388. So here we have decrease. All right, let's try the next number. From 29, the next one would be 50. From 0.388 to 0.217, that goes down. That's a decrease. Okay, and now next we've got 51. From 0.217 to 0.05, that's a decrease. Okay, then our largest atomic number is 82, and our last one is 0.119, that's the lowest. So for all of these values, it decreased only. So our answer for 31 should be B. All right, 32. 32 was another interesting one that you had to know a little bit from class. You had to have a little bit of background knowledge. For here, they ask you to calculate the percent error for the specific heat of Cu. Okay, so Cu, we know we're focusing on these values here. And if you weren't sure which numbers to use, you can look here. It looks like they're only dealing with the 0.388 and the 0.384. So we're trying to find the percent error between these two numbers here. Okay, percent error is something that I do with my AP Environmental Science and AP Bio kids. So maybe it's something that you've also seen in math or in a higher level science class. This is the formula I put on this little sticky note over here. I always tell them when they ask you to calculate percent error, no times 100. You don't want to do it. It's math. Oh no. So the formula is NOO times 100, or new minus old divided by old times 100. Okay, so our new number will be the number that they found in their experiment. Here is the new number. And our old number is the accepted number that all scientists agree on. Okay, so if we do new minus old divided by old, that would be 0.388 minus 0.384. So it's going to be one of these two, F or G, divided by old, so divided by 0.384, and that would be F. And then you times 100 to turn it into a percent for percent error. Okay, now the reason they're not asking you to actually provide the value is because you do not get a calculator on the science section. You only get a calculator in math. So you're giving the setup, but not the answer. So again, remember this helpful little formula. Percent error, no times 100. I don't want to do percent error, no. New minus old divided by old. All right, last question, number 33. 33 asks, based on the experimental procedures, aka the steps of the experiment. This is the only one where you actually have to read the steps of the experiment. Okay, and they say in each trial, a total of how many temperature values were recorded. So again, I'm not going to read this whole thing. That would take forever. This is a timed test. I'm just going to skim for temperature. Okay, and here I see they're going to record the temperature every half second. Okay, for 100 seconds. And then they're going to record it again every half second for 120 seconds. Okay, if I'm recording it every half second, that means I have 2 recordings or 2 values per second. So this section for step 3, that would be 200 recordings because I've got 100 seconds and I'm recording it every half second. So 2 recordings per second. 200 recordings. And then here I've got it for 120 seconds. If I'm recording every half second, that's 240 recordings because you're going to again have 2 every second. If I add these 2 together, add them, 200 plus 240 is 440. So my answer for 33 is D. That one was a little bit tougher, but again, totally doable if you have the time and you can slow down and skim for your answer. Thanks for watching. Have a great day.